For part 3 of the videos talking about complex numbers, we want to spend some time talking about using the quadratic formula to find our two solutions to a quadratic equation. Now, to be able to view this part of the video, you've got to know a few things. First of all, what is a quadratic equation? Well, a quadratic equation is an equation that has an x to the second power in it, okay? And you've got to know a little bit about complex numbers. If you don't know anything about complex numbers of the form a plus bi, then you need to watch videos 1 and 2 for complex numbers. So I'm assuming that you know all about simplifying complex numbers and you have some old history dealing with the quadratic formula, but I will review that here. So if you, again, you have a quadratic equation, you'll see one right in front of you. 3x squared plus 3x minus 2 is a quadratic equation. What is required to be able to use the quadratic formula is your quadratic equation has to be in descending powers order. So notice you have an ax squared plus a bx plus a c equals 0. So squares first, the x term is next, and the c term is last. And so notice that's in the right order. And our problem over here is also written 3x squared plus 3x minus 2 is equal to 0. Okay? And your a is the number in front of x squared. So in our problem right here, our a is equal to 3. Our b is equal to 3 also. It's the number in front of the x. And our c is equal to negative 2. Okay, so a is 3. B is 3, and C is negative 2. Let's see if we can simplify or find the two solutions to this equation using the quadratic formula. So I have x is equal to negative b. So that's going to be negative of a negative or positive 3, because our b is 3, plus or minus the square root of b squared. So it's going to be 3 squared. Minus 4 times a is 3, and c is negative 2. Now all that's underneath the square root, and that's all divided by 2, and then a is 3. Okay? And again, my apologies about this pen. It has some writing issues. I'm working on it. So negative of a positive 3 is negative 3. Plus or minus the square root of 3 squared is 9 minus 4 times 3 is 12 times negative 2 is going to be positive 24, and that's all divided by 2 times 3 is 6. So I continue to the right, simplifying. That's going to be negative 3 plus or minus the square root of 9 plus 24 is 33. All divided by 6. Okay, and if I could simplify the square root of 33, I would, but there's not a perfect square that divides evenly into 33, so this is as simple as it gets. So my final answer is, and there's two results. One of them is x is equals to negative 3 plus the square root of 33 divided by 6. The other is negative 3 minus the square root of 33 divided by 6. And that's my two results. All right, so we have another quadratic equation that we're asked to solve. Well, first of all, is this quadratic? Well, yes, it's got an x squared is my highest power, so this is a quadratic equation. So step 1, done, it's quadratic. Step 2, it needs to be in the right order. Is this in descending powers order, just like the ax squared plus bx plus c? Notice it is. So that means our a is 1, our b value is negative 2, and our c value is 17. Right? So a is the number in front of x squared, b is the number in front of x, and c is your constant value. Notice I also took the signs with it. That's a positive 1, so I put 1. It's a minus 2, so I put negative 2, and 17 is positive, so I put 17. Now let's plug in our formula. So I have x equals, that's going to be negative b, so negative of a negative 2 plus or minus the square root of b squared. So it's negative 2 squared. Notice the parentheses are required because I'm squaring the negative and the 2. Minus 4 times a is 1, c is 17, and that's all divided by 2 times a is 1. I'm going to continue simplifying to the right. So the negative of the negative 2 turns positive 2. Plus or minus the square root of negative 2 squared is 4, because negative 2 times negative 2 is positive 4. Minus, and then I do 4 times 17 to get 68. And that's all divided by 2. So I continue simplifying. That's 2 plus or minus the square root. Now 4 subtract 68 is negative 64. All right, now you realize why this type of problem is in this section. Until this section, we would just say that's not real, and this quadratic equation doesn't have any real solutions. But now that we know all about complex numbers, we can come up with the two solutions because we have a negative under a square root. Again, with a negative under a square root before today, we just left it right there. It's not real. That's all we would say. Oops, not real, I'm done. Now we know how to simplify the square root of negative 64. So now I have 2 plus or minus. Remember, the negative is an I value. And then the square root of 64, we all know, is 8. So that's 2 plus or minus 8i over 2. Now, 2 cannot be added to 8i. They're not like terms. You got a real number and an imaginary number part. But now what I can do, just like I did when I did division, I can put the 2 underneath each of these separately. So I could say 2 over 2 plus or minus 8i over 2, which simplifies to 1 plus or minus 4i. Those are my two solutions. One of them is x is equal to 1 plus 4i. The other one is x is equal to 1 minus 4i. Because practice makes perfect, let's try another one of these. So first thing is this quadratic. Yes, it is, because it's got an x squared right there, 2x squared. That's what makes it quadratic. The next thing is you have to get it equal to 0. So what I need to do is I need to add 3 to each side of this quadratic equation. So now I have 2x squared plus 2x plus 3 equals 0. Okay? Another way to think about this is anytime you need to move a term to the other side, it just changes the sign. It's negative 3 on the right, so when you move it to the left, it's positive 3. Now from here, I can see that a is the number in front of the x squared. It's called the x squared coefficient is 2. B is also 2, and c is 3. But notice it has to be equal to 0 before you can establish what a, b, and c are, because if you left it the way it was, you would have c as negative 3, and that's not right. It's positive 3. So now I'll plug it in the formula. So I have x is equal to negative b, or b is 2, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a is 2, c is 3, and that is all divided by 2 times a, so 2 times 2. Now the rest of the process is just simplify this into lowest terms. So 2 squared is 4, 4 times 2 is 8, times 3 is minus 24, and that's all divided by 4. So I continue simplifying, gives me negative 2 plus or minus. Now 4 subtract 24 gives me a negative number. Anytime you have a negative under a square root, you know you have an imaginary number to deal with. Again, before this lecture, we didn't have imaginary numbers. We would just say, hey, this is not real, and we'd be finished with it. But we're not allowed to do that anymore since we know all about imaginary numbers or complex numbers. So what I'm going to do is break this down. So it's negative 2 plus or minus. Now, I know the square root of a negative is I. Okay? 20 we can break down into the square root of 4 times the square root of 5. Now what I'm doing is I'm looking for the biggest perfect square that divides into 20. And perfect squares are 2 squares. 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square. Well, the biggest number on that list that divides into 20 is 4. So I broke it down into 4 times 5 because that gives you 20. I keep simplifying. That's negative 2 plus or minus. Now the square root of 4 is 2. So I'm simplifying that, and I'm writing it as 2I square root of 5 over 4. And then over here in green, I'm going to write my final answer. Okay. I can split this up, so I can say negative 2 over 4 plus or minus 2I square root of 5 over 4, and then reduce these fractions to lowest term. So this is negative 1/2 plus or minus this 2 and this 4, leave a 2 in the bottom, I square root of 5 in the numerator. Of course, that's x equals. It's two answers. One of them is x equals negative 1/2 plus I square root of 5 over 2, and the other one is x equals negative 1/2 minus I square root of 5 over 2. Okay, those are your two different solutions to this quadratic equation. And finally, our last problem. The more of these you do, the better you'll feel, I promise. So first of all, we're supposed to solve this equation, which means find the x values that make this true. So to do that, I have to know what type of equation I have. It's quadratic because it's an x squared. And quadratics need to be set equal to 0 before you either try to factor them or solve them. And so what I'm going to do is I'm going to subtract the 4x over. That's going to make that 3x squared minus 4x. And I'm going to add the 6 over. So plus 6 equals 0. So notice what I did. I want to keep the 3x squared positive. It's always easier to work with your problem when a is positive, and move the positive 4x over to make it negative 4x, and move the negative 6 over to make it positive 6, which means a is 3, b is negative 4, and c is 6. And then I plug that in my formula, so I have x is equal to negative of a negative 4 plus or minus the square root of negative 4 squared. Those parentheses right there are required. Minus 4 times a is 3, c is 6, and this is all divided by 2 times a is 3. I continue simplifying. The negative of negative 4 is positive 4 plus or minus the square root of 16. 4 times 3 is 12 times 6 is 72 over 6. That's 4 plus or minus the square root of 16, subtract 72, is negative 56, all divided by 6. So I need to simplify. Now I've got to find the biggest perfect square that divides into 56. I also know that the negative under the square root is an imaginary number. So we could play around with 56 is divisible by 4. And it goes 14 times, which tells me that is the biggest perfect square that divides into 56. So I have 4 plus or minus, again, the negative underneath is I. 56 I'm going to rewrite as the square root of 4 times the square root of 14 over 6, which means this part, I'll highlight it for you, I square root of 4, I can rewrite that as 4 plus or minus 2I, because the square root of 4 is 2, and the I just put behind it, square root of 14 over 6, which gives me x is equal to, now I can split these up into two separate fractions, 4/6 plus or minus 2I, square root of 14 over 6. 4/6 is 2/3 plus or minus the 2/6 gives me 1/3, or I could just write I square root of 14 over 3. So that's my two answers. If I write those split up, that would be x is equal to 2/3 plus I square root of 14 over 3, and x is equal to 2/3 minus I square root of 14 over 3. And then I am finished with that problem. So I hope this helps. That completes our discussion about complex numbers.